Hello everyone, welcome back. Now we will enter the second part of today's course, low-string PIT theoretical curve analysis. In this part, our teacher will explain what wave impedance is and how the change of wave impedance affects the low-string detection waveform. If you have any question during the course, you are welcome to share your question, and we will have more discussion about the question. Now the class begins.
Theoretically, we can predict that several kinds of defects will be collected correspondingly to several curves. So this course is mainly to analyze the theoretical curves. This is the schematic diagram of the rod top velocity time history response curve. On the left is a rod and the process of stress wave propagation in the rod, including the expression of the difference between the upper impedance and the lower impedance. The upper part on the right is a velocity time history response curve, and the lower part is the path diagram of stress wave propagation. When the stress wave reaches an interface, it will produce corresponding reflection and transmission. According to the reflected signal, we can roughly analyze the impedance change of the rod according to the velocity time history response curve. Next, let's look at the law of stress wave propagation in the foundation pile. First, let's look at the influence of the impedance change of the pile body on the velocity response curve. A schematic diagram is drawn on the right. A pile body has two kinds of impedance, and an interface is drawn in the middle. There are several possibilities for these two impedances. Let's take a look at the first case. The two impedances are basically the same. Z1 is about equal to Z2. We can see that there is no reflected signal between the pile head and the pile bottom in the time domain curve, because Z1 and Z2 have little difference. There is no obvious wave impedance change interface. It can be said that basically all stress wave signals pass through this interface until the pile bottom is reflected. Therefore, what we see on the measured curve is the incident wave curve of the pile head and the reflected wave signal of the pile bottom. If the upper wave impedance Z1 is greater than the lower wave impedance Z2, that is to say, there is an interface with reduced wave impedance in the pile body. This reduction interface is only represented by the interface on this schematic diagram. In practice, it may be segregation or mud inclusion. These represent changes in wave impedance. So what can we see on the measured curve? According to the propagation law of the previous stress wave, we can get that on the interface where the wave impedance decreases, a reflected wave in the same direction as the incident wave will be generated. It can be seen from the time domain curve that after the incident wave at the pile head, we can see a relatively small amplitude of the same direction reflection wave. This same direction reflection wave is the reflection wave generated by the impedance reduction interface, followed by the reflection formed by the transmission of energy to the pile bottom, which is the reflection wave at the pile bottom. When the upper wave impedance is smaller than the lower wave impedance, that is, Z1 is smaller than Z2. In practice, there are more cases of diameter expansion. It can be seen from the time domain signal that a reflected wave opposite to the incident wave is generated at the interface change after the pile head is incident, which corresponds to the interface with increased wave impedance. Finally, there is a pile bottom reflection wave in the same direction. We have just seen some situations in which the wave impedance decreases and increases in practice. In the actual inspection site, it is impossible to reduce the diameter to the bottom or expand the diameter to the bottom, and there are often reduction in the middle process. The pile body will produce a reflected wave in the same direction as the incident wave at the interface with reduced wave impedance. But when it is restored from the reduced interface to the original interface, it will produce a reflected wave, opposite to the incident wave, with a schematic diagram of a curve drawn in the middle. From the time domain curve and stress wave propagation path diagram on the right, we can see that the incident wave is in the front, and there is an isotropic wave at the interface with the same direction as the incident wave and reduced wave impedance in the middle. After this same directional wave is a reverse wave, which is the process of wave impedance reduction. The reflection of the pile bottom is simulated based on the state that the pile bottom is free, or the wave impedance is very small. Similarly, we may also face the process of restore after the increase of wave impedance, which is opposite to the situation just now. That is, at the interface of the increase of wave impedance, we will first see a reverse reflected wave, and then in the process of wave impedance reduction, it is still small relative to the original impedance. So a reflection wave in the same direction is generated. Of course, it is based on the free condition of the pile bottom that generate the reflection of the pile bottom. I believe this is easy to understand. These are based on the reflection caused by the change of wave impedance mentioned above. Only with a preliminary understanding can we better understand the process of impedance change and restore. In the signal curve of field test, you will often see that after the previous reflection, there is a small amplitude and a reverse reflection. We don't need to judge that it is a defect, because this situation is the process of defect restoration. A conclusion is drawn according to the influence of the change of pile impedance on the curve we tested. When the pile defect is serious, there will be primary, secondary, or even multiple reflections at the position where the wave impedance decreases, and the reflected wave and the incident wave must be in the same direction. When the diameter of the pile is expanded seriously, there will be 1, 2, or even multiple reflections at the position where the wave impedance increases, and the odd number of reflected waves are opposite to the incident waves. The even reflection wave and the incident wave are in the same direction. When the wave impedance changes more, the amplitude of the reflected wave is more obvious. We just see the change of pile body impedance. Similarly, the bearing layer at the pile bottom will also have some influence on the signal. Compared with the pile body, the impedance of the bearing